Continuing with our procedures for hypothesis testing, we'll go to the mean, where sigma, the population standard deviation, is known. So as with the confidence interval estimates, we have the same requirements. The sample is a simple random sample. The population standard deviation sigma is known, and either or both of these conditions are satisfied. The population is normally distributed, or the sample size is greater than 30. And of course, both of those could be the case. The test statistic is the same as for the confidence interval estimate. It's a z distribution, or the normal distribution. So our test statistic is a z. With the numerator x bar minus the mean of the sample means divided by the population standard deviation over the square root of n. And I like to put this in parentheses because a lot of students will enter this in the calculator when they do want to calculate the z statistic, and without those parentheses you'll end up getting the wrong result. You also would need parentheses around your numerator. The methods we'll use, you will not need to calculate the test statistic as it is by itself. The TI-8384 technology will do that for you, but it's important to note what it's made up of. Okay, so as we did with the proportion, we'll use the TI-8384 technology to compute this test statistic and the p-value. And then we'll use both of the methods that we've learned to make our decision. So recall the traditional method requires that we look on our decision diagram, we look to see if the test statistic falls in the critical region. If it does, we reject the null hypothesis. Our second method is the p-value method. If the p-value is less than or equal to alpha, our significance level, we reject the null hypothesis. Otherwise, we write the words, we fail to reject the null hypothesis. Recall, those are our two choices with the decision: reject the null hypothesis or fail to reject the null hypothesis. So we'll use a decision diagram and the information we have obtained from our technology after we put in the correct information to make our decision, and our decision will be one of these two. And then we will use the flow chart that we've seen before to form the wording of our conclusion. So recall that when we form the wording of our conclusion, we start with the question, does the original claim contain the condition of equality? And I just want to run through this again to help this make sense to you. Remember, as we're determining what our alternate hypothesis is, the first thing we're doing is writing the original claim, the competing claim, HO is always the equal sign, and then we determine what our alternate hypothesis is. We have found that sometimes the original claim does correspond to the null hypothesis. The original claim does contain the condition of equality. We have also seen examples where it is the competing claim that contains the condition of equality, and it's the competing claim that corresponds to the null hypothesis, and the original claim corresponds to the alternate hypothesis. So that's how we answer this question. Sometimes the answer is yes, and that means the original claim and the original claim and the null hypothesis correspond. If we say no, then that means that the original claim and the alternate hypothesis correspond. So let's just go through this a little bit and think about it. So if we say yes to this question, yes, that the original claim does contain the condition of equality, then our decision about the null hypothesis is the same as our decision about the claim, because they correspond. So if we reject the null hypothesis, we're rejecting in essence the claim. If we fail to reject the null hypothesis, we fail to reject in essence the claim. So let's look at no, of course. If our answer to this question is no, in other words, the null hypothesis does not correspond to the original claim, then if we reject, our decision is to reject the null hypothesis, then the opposite is going to be true about the claim. So if we say no to this question, our decision about HO is the opposite of our decision about the claim. Here it's the same, here it's the opposite. Here they do not correspond, here they do correspond. Okay, so let's take this a little further with our understanding. So if we say yes, that the null hypothesis and the original claim correspond, then if we reject the null hypothesis, then we say, well, there's sufficient evidence to reject the claim because they correspond with each other. Reject HO, we have evidence to reject the claim. If we fail to reject and they correspond, then we say, well, there's not sufficient evidence to reject the claim. We can't reject the null hypothesis based on our data, so we can't reject the claim based on our data. They correspond. If we say no, and we decide to reject HO, then the sample data support the claim because our decisions are opposites. They do not correspond. So rejecting the null hypothesis is actually having evidence to support the claim since they do not correspond. If we fail to reject when they do not correspond, then there is sufficient evidence, there's not sufficient evidence, to support the claim. So we cannot reject HO, therefore we don't have evidence to support the claim. The opposite response here. Okay, so if we fail to reject HO, in other words, we don't have evidence to reject it, here we don't have evidence then to support the claim. Okay, so I'm just trying to make this conclusion make sense and not just have you go through the flow chart without really understanding what you're doing. It's the same thing as when we're trying to determine our alternate hypothesis. Which one does it correspond to? Original claim or competing claim? Which one does HO correspond to? Original claim or competing claim? If HO and the original claim correspond, the decisions match. They're the same. If we reject HO, we're rejecting the claim. We fail to reject HO, we're failing to reject the claim. If they do not correspond, then we see opposite decisions here. Reject HO, support the claim. Fail to reject HO, we cannot support the claim. Okay, I just wanted to take a few minutes as we continue through hypothesis testing to make this conclusion make a little more sense to you.